Welcome back, all my aspiring mathematicians. Today I am going to show you how to find the altitude of a given right triangle. Now let's first define an altitude. An altitude of a triangle is simply a line segment that is extending from the vertex of the triangle to the segment that is opposite that vertex. And usually that line segment creates a perpendicular line to that opposite line segment. The altitude of a triangle doesn't necessarily have to be inside of the triangle. In an instance where you will have an obtuse triangle, the altitude of that triangle is going to be on the outside of the triangle. One thing you must know is that when we are dealing with a right triangle and you have the altitude forming in the right triangle, it is going to subdivide that triangle into two other right triangles. So let's first show you what an altitude would look like in a given right triangle. So this is the right triangle that you have, right? We know that this is one of the legs, this is the other leg, and this is the hypotenuse, because the hypotenuse is always opposite the right angle. So if I'm to draw an altitude, I'm going to draw an altitude from the vertex that is going to be perpendicular to the opposite side of that triangle. So let's draw my altitude. And we would also denote with this square right here. We will also denote the square right there because this will tell you that it is now a right angle to this line segment, which is now the altitude. So this is our altitude. So you will notice that from the main triangle that was given to you, triangle XYZ, the altitude subdivided that main triangle into two sub-right triangles. And we will now also label this as W. So if I have this label as W, we can now say triangle WYZ is one triangle and triangle WXY is another triangle. So you have two triangles there. There are special relationships that are being formed when you have an altitude in a right triangle that subdivides that big triangle into two other sub-right triangles. And let's first define the first one. And for the first one, what I'm going to do, I'm going to label, we know that this is the hypotenuse, this is the short leg, and I will say short leg here, all right? And this is the long leg, and this is the hypotenuse. And we're talking about triangle X, Y, and Z, and that is how you define it. Now I'm going to label triangle 1 right here, which is triangle WYZ. And first, let's highlight this because I'm going to highlight it to show you that we have different types of triangle forming here. We will now call this leg the hypotenuse, right? And now this is going to be the short leg, S for short, and this is going to be the long leg, and we can say LL for triangle 1. Now I'm going to look at triangle 2, and triangle 2 would be triangle XYW. And I'm going to make this bigger here. Notice that LL from our main triangle is now going to be the hypotenuse, and that is the side that is opposite the right angle. And then for this segment now right here, this is going to be our short leg, and this is going to be our long leg right here. It is very important that you label the two sub-triangles that are formed from drawing the altitude on that first triangle. And the reason why you will do that is because you are going to use the ratio method to find the altitude of a given triangle when it is subdivided. So let's get into our first example. So our first example here is that you're given the triangle ABC and you're asked to find the altitude, which is y, on this given triangle. So we are going to use a ratio to find this triangle. But as I stated before, always label your triangles, and so you will get an idea of what to do. So we have the main triangle here. We have this is our hypotenuse, and this is our long leg, this is our short leg. But in this triangle, and I can label it as triangle 1, I now have 4 as your short leg, and this is going to be your long leg, and this is going to be your hypotenuse. However, for triangle 2, which this I will label this as triangle 2, you will notice that this is going to be your long leg, this is now going to be your short leg, and this is going to be your hypotenuse. And as a matter of fact, I labeled long leg on this side, but let's label it on this side so you're not confused. I'm not going to be confused because I know my stuff. But for you who is a beginner, then I would suggest that you label it over here. So put a line through there. So once we have this, we can use the ratio method to find the altitude, which is y. So let's start off first with our ratio method, and we are going to set up using a ratio of short leg over long leg, right? Set it equal to also short leg over long leg. You have to use the same ratio when you are setting each one equals to the other. So now we can identify using triangle 1, right? I'm going to set up my short leg is going to be 4 over our long leg, which is y, the unknown, and I'm writing 1 here as my first triangle. And then for my second triangle, I am going to write 2 over here so you understand. And I'm going to also use short leg, which is y, over long leg, which is 9. And we set it equal to each other. If you are incorrect in setting up your ratio in this method, your answer is going to be incorrect. So you have to be careful when you are labeling each part of your sub triangles that you have formed from the main triangle. So now let's do the math. So we are going to cross multiply, and that's how we solve for a ratio. We're going to cross multiply. So we will have y times y is y to the second power equal 4 times 9. So y squared is equals to 36. So for us to find what y is, then the proper way to do it is now we are going to find the square root of both sides, right? And we will end up, because the square root is going to erase raising the exponent, which is 2. So you're going to be left with y equal 6. In actuality, normally y equals plus or minus 6 when you are finding the square root. So we can say y is equals to 6. And you can test this, because I always tell my students, when you get an answer, check your answer. And the way we test this or check our answer is that we will now have y 6. So we are going to rewrite our proportion, and we are going to substitute what we have for y, which is 6. So 6 goes here, and we're going to cross multiply. Okay, so 4 times 9, and then set it equals to 6 times 6. So 36 is equals to 36. So yes, that is correct. And that's how you check your work. Okay, so as you should know by now, I always give more than one example. In this case, you are given the numbers on the hypotenuse of the big triangle, and you were asked to find the altitude. Now, the next example I'm going to give you is going to be a little bit different. So in this example, we have the main triangle here, and all measurements were given on the main triangle, but as usual, we don't have the measurement for the altitude of this triangle. So we have to label the main triangle, since all the measurements were given on the main triangle, and I will label it accordingly as this is going to be the hypotenuse, and this is going to be the long leg. This is going to be the short leg. All right, SL. I'm now going to call this triangle 2, right? And with triangle 2, I'm going to label also accordingly. With triangle 2, this is now going to be the short leg. This is going to be the long leg, which we don't know the measurement there. And this is now going to be the hypotenuse for triangle 2. I can take it further and continue and label this. We will call this now triangle 3. Triangle 3, this would be the short leg, this would be the long leg, and this would be the hypotenuse. Look at the colors for the diagram, and it is very important that you do this using various colors so they are concise and you can gain clarity when you are doing your work. Now, we're not going to use the same short leg over long leg ratio. In this case, I'm going to look at this and I'm going to determine which ratio I am going to use. And how you do that is because if I look at triangle that's labeled 3, I don't have a measurement here for long leg and I don't have a measurement for short leg. So I can't use that short leg over long leg ratio. No, I can't. However, even for triangle 2, the same scenario. I cannot use the short leg ratio over long leg ratio because none of these measurements are given, and I need to have at least one of those measurements in order to find it. And obviously, if we're finding the altitude here, then we can't use a short leg over the long leg because this is also the long leg and that is not given. So I am going to use a different ratio, which is the short leg over the hypotenuse. And if I even tried with triangle 3, short leg over here over hypotenuse, that short leg is not the altitude. The short leg is this leg over here. So because the question is asking you to find the altitude, which is the segment BE, I'm going to use the main triangle and triangle 2 ratio of short leg over hypotenuse. So let's get right into it. So I have my short leg over my hypotenuse, set it equals to short leg over hypotenuse. I'm going to write on top of here that I'm dealing with the main triangle first, followed by triangle number 2, because I can't use triangle number 3 because there's no measurement here for the short leg. So for triangle 3, I'm finding the altitude, which would be the long leg, and no, I'm not using that as my ratio. So I cannot use triangle 3. I must only concentrate on triangle 2 and the main triangle. So let's set up our ratio now. Main triangle, I have my short leg, which is 12 over hypotenuse, which is 20. And set that equal to triangle number 2, which is the short leg is the unknown, which is segment BE, over the hypotenuse there, which is 16. Now I'm going to cross multiply as usual because that's how you solve for proportion, and you cross multiply. So by cross multiplying, I will end up with 20 BE, a segment BE is equals to 12 times 16. Right, and so 20 BE, the segment there is equals to 192. I will need to find what BE is going to be. So BE, for segment BE is going to be equals to, dividing both sides by 20, I'm going to get 9 and 12 over 20. And you can further reduce that to BE is equal to 9 and 3/5. All right. And that is the measurement for your altitude. Now, as you know by now, that variety is the spice of life, and this is not the end all be all. I have to give you another example wherewith you're using a different ratio, and also you're going to notice that something is unique with this. So for this example, you still have to find the altitude, which is FH. And we will notice that only 2 measurements are given in this case. So let's label first, and then I'm going to show you something and take it from there, because by labeling it, you're going to notice something very unique about this. So this is our main triangle here, and we are only given 2 segments, which is the short leg and the long leg measurements. There's no hypotenuse. If we need to find FH now, and if we call this triangle 2, we will notice that this is going to be our short leg, this is going to be the hypotenuse, and this is going to be the long leg. All right, so let's think about it. Can I use long leg over hypotenuse? If I use long leg over hypotenuse here, for the main triangle, I don't have a long leg over the hypotenuse. I don't have a hypotenuse for the main triangle. So let's label the other triangle as triangle 3. All right, because the main triangle is triangle 1 in a sense. So with this, now this is going to be my short leg, and this is going to be my long leg, and this is going to be my hypotenuse for triangle 3. Now, am I going to have a short leg over hypotenuse situation that I can use? If I use short leg over hypotenuse, then for this smaller triangle, I can't use short leg over hypotenuse because the short leg is unknown. If I try it with the main triangle, I don't have a hypotenuse measurement here. So because of that, in this scenario, you have to find the length of the hypotenuse. So this is very unique because the other 2 examples, you didn't have to find the hypotenuse first. One, the hypotenuse was given to you in one measurement, and the other one, it was split in 2 for the 2 triangles. First, let's find the hypotenuse for this main triangle, and then we will be able to use that and use any of the ratios to find the measurement for the altitude. So let's get into it. We are going to start out with our Pythagorean theorem formula, which is c squared equals a squared plus b squared, or if you choose to write it as a squared plus b squared equals c squared, that is fine. So for this scenario, EG is going to be our hypotenuse, and then our leg, it doesn't matter which is the short and which is the long one, we will have 2 radical 5 to the second power plus radical 7 to the second power. Now we will continue with this, and we will have segment EG to the second power is going to be raising 2 radical 5 to the second power is going to give you 2 to the second power. You're going to separate them, and then you have radical 5 to the second power here, plus this is going to give you 7, because a radical raised to this exponent 2 is going to give you 7. And if you need help on that, you can go back and watch my video on that, and that will help you. Now we will continue with EG to the second power is equals to, now we have 4 here. This is going to give you 5. 4 times 5, let's put it in parentheses, plus 7. So we will have 20 plus 7. Okay, EG2. And EG to the second power, segment EG to the second power, is going to be 27. So we're not finished. We need to find EG. EG, segment EG, is going to be equals to the square root of 27. Now, the square root of 27 is irrational, and we have to further break it down. So we can break it down in the square root of 9 and the square root of 3. So EG, segment EG, is going to be 3 radical 3. And that is what you have for that segment. So we're going to use this in our example over here, and we can write it on here now, because EG is going to be 3 radical 3. Now we have that. We can go ahead now and use any one of the ratios, whether we are going to use the short leg over hypotenuse, or we can use long leg over the hypotenuse to get our answer. Because if we use short leg over the hypotenuse, then we have the hypotenuse here, and the short leg for the main triangle we need to now label the main triangle because we didn't do that first. So for the main triangle, which is in blue, this is your short leg here, this is your long leg, and this is your hypotenuse right here. The only two possible ratios that we can use in this scenario is long leg over hypotenuse, or we can use short leg over hypotenuse. We cannot use short leg over long leg. Nope, that's because this is unknown here and it is also unknown over here. So just be careful there. So if we use short leg, right, over our hypotenuse, set it equals to short leg over hypotenuse, and I'm going to deal with the main triangle, M triangle. Then I'm going to set my ratio as my short leg for main triangle is radical 7 over hypotenuse, which is 3 radical 3. Set that equal to, use my next example here, which one has the short leg. The short leg is the altitude, which is here, right? So I can use that is the unknown, which is FH, segment FH, over the hypotenuse, which is now 2 radical 5. And we are going to cross multiply as usual for this scenario. So cross multiply as usual, we will end up with 3 radical 3 FH, which is a segment. Set that equal to radical 7 times 2 radical 5, right? And that is going to give you 2 radical 35, right? And you cannot break down that any further. This is what it would be, and then you just have to divide both sides by 3 radical 3, and you will notice that segment FH is simply going to be 2 radical 35 over 3 radical 3, and that cannot be broken down any further. This is what it would be, the altitude. If you decide to go with the other ratio, and let's test it. For the other ratio of long leg over hypotenuse, set it equals to long leg over hypotenuse. And then using the main triangle, oh, I forgot, I did not note which triangle this one was that we were using. That would have been triangle number 3. Okay. So for our main triangle here, we are going to use our long leg, which is 2 radical 5 over our hypotenuse, which is 3 radical 3. Set that equal to, even if I use my long leg, which is triangle 2, we're going to use now. It has to be triangle 2. Just want to note that. So for one example, first one we use triangle 3, comparing it to the big triangle, and then for this other ratio, for long leg over hypotenuse, we are dealing with triangle 2, which is comparing it with the main triangle. So for triangle 2, my long leg here is the altitude, which is missing, and FH, which is segment FH, over the hypotenuse, which would be radical 7. And because we cross multiply, we will notice that we will end up now with 3 radical 3 FH equal radical 7 times 2 radical 5. And 3 radical 3 FH, which is a segment, is equal to, we have to work that out, 2 radical 35. And FH, or segment FH, which is the altitude, is 2 radical 35 over 3 radical 3. And we cannot further break this down. So this would be your answer. Notice you arrive at the same answer. And if you don't believe me, I can test this to show you that SL, which is the short leg, over the long leg ratio is not going to work. And let's get into it. If I try to use the short leg over long leg ratio, so my short leg for my main triangle is radical 7 over long leg, which is 2 radical 5, set it equal, that's my main triangle. And for the one with short leg, I would have to use triangle 3. So triangle 3 I would have to use in this case. So what you will notice, because of that, triangle 3 would be FH, that's that segment for the altitude. Set it over long leg is the unknown. We don't know the long leg for triangle 3. We only know the long leg for the main triangle. So we can't use that ratio. All right, so I just wanted to prove that to you. Unknown. Unknown. We can't use this ratio. All right. So in conclusion, now that you know how to find the altitude of a given right triangle, which is subdivided into two other similar right triangles, we will use the ratio of either the short leg over long leg, or we could use a ratio of short leg over hypotenuse, or it could be long leg over the hypotenuse ratio. I hope that you will label your triangles when you get them. You will start off with the main triangle, then you will have the sub triangles, as label them as triangle 1 and triangle 2, and then you have to label them accordingly with the side that is the short leg versus the side that is going to be the long leg, so the long leg and the hypotenuse. So you have to label each parts of your triangles like that, and also your main triangle. So just be careful with that. As I stated before, use different colors when you are labeling your triangles, and be careful when you are labeling your two sub triangles that are in your main triangle. So with that being said, if you have not yet subscribed to my channel, what are you waiting for? Go ahead and hit that subscribe button. And please hit the like button also if you like what you see. And share this with others around the world so they too can be successful when they're given the next math problem that is asked to find the altitude of a right triangle when it is subdivided into two other sub-right triangles. And please leave me a comment. And thank you for watching, and see you soon on the next video to come. Bye now.